The following content is created by Dr. Dravitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome back, guys. My name is Dr. Dravitech, and in this video, we're going to talk about the first shift theorem or the first shifting theorem. Remember to make sure that you set the video quality to the highest resolution and then make sure it's full screen so you see the board clearly. All right. Now, there are different names for this. So you can call it the first shift theorem. You can call it the exponential shift theorem. You can call it the first shifting theorem. You can also call it the S-shift theorem. So here's what we're going to do. What does it actually mean? In my own case, I like calling it the multiplication by exponential. I prefer calling it that, and you'll see why very soon. Remember to hit the subscribe button, like this video, and share it across to your classmates. Now, mathematically, remember that the Laplace transform of f of t is the integral from 0 to infinity f of t exponential minus st dt. So this is what it is. And remember, this will equal f of s. So this is the definition for Laplace transform. Now, if we have the exponential, so when we multiply the function by an exponential, so let's say the Laplace transform of, instead of f of t, we have e, so negative at f of t. So that's why I kind of like calling this one multiplication by e to the minus at, because we're multiplying the function by something like this. So in this case, this will be integral from 0 to infinity. We then have e of minus at f of t, e to minus st dt. So we're trying to find out what this will equal to. So what I would do is, since these two guys have the same base, I'll say this is integral from 0 to infinity f of t. Then together, both of them will become e to negative st negative at dt. What I just did is I applied the laws of indices here. They have the same base, so I'm going to add up the powers. But of course, if I have a minus, if a plus comes in, it's still going to be a minus. And then I'm putting the minus st first, because s is first here. I also want the s to be the first here. And the minus 80 comes later. It's still the same thing. Now this will become integral from 0 to infinity, f of t. Then this is e. Take a look at this. This is, the t is common, and then the negative. So I want to look somewhat like this. So this will become negative t into, when minus cancels out minus and t cancels out t, I'm going to have s, and then minus minus will give me plus, at over t is a, and then we have dt. So this is what we have. Now slow down a little bit. We're actually close to our answer. If you compare this to this whole expression is equal to f of s. And the only portion we have s is this very one here. So I can kind of write this as, just for the sake of explanation, because st is same thing as t times s. So it's still the same thing. Now, you notice that the bracket here has s, so we have f of s. But what if this s here, if you compare it to this, these two integrals are almost the same. The only difference is the bracket. So if this is s, and now we have s plus a, this means instead of this integral to be f of s, this integral will equal f of s plus a. Because that's what the bracket is now going to be. So instead of f of s, this very s here, we now have f of s plus a. That's the first shift theorem. It's actually very easy. So this means that the Laplace transform of e to negative at f of t is equal to this. Now, what if this negative 80 is just 80? Do not stress yourself. If this is just e to the 80 f of t, what this means is this will be f to the s minus a. So take note, if here is minus a, here has to be plus, and if here is positive, here has to be what? Negative. That's just it. Now, how do we then apply this when solving problems? Now let's say the first question we have is for us to find the Laplace transform of e to minus 2t t to the power of 3. Let's say we have something like this. Now the first thing is, what is the Laplace transform of t to the power of 3? And Laplace transform of this will become 3 factorial divided by s to the power of 3 plus 1. Remember in the previous video, we did the Laplace transform of t to the power of some number. So what we're going to do is this very number, we're going to say 3 factorial divided by s to the power of 3 plus 1. Always check the previous video and watch the video in the playlist because these are all prerequisites to understanding the future videos. Now 3 factorial here will give us 6 because that's 3 times 2 times 1 over s to the 4. So this will become 6 over s to the 4. Now, if we're looking for the Laplace transform of e to negative 2t t cubed, this will become, now we have 6 over, this is s to the 4. But instead of writing s, I'm going to be replacing s with s plus 2. So this will be s plus 2 to the power of 4. Because this is minus 2. Now if you come here, this minus here means I'm going to be replacing my s. Anywhere I see s, I'm going to replace s with s plus a. So this will have minus here, this will become s plus 2. That was why I replaced the x here with x plus 2. That's just the first shift. It's basically the same thing as finding the Laplace transform of something. But then, anywhere we see s, we're going to replace s with s plus a. That's what we're going to be doing. Let's take a look at another example. 2. We have the Laplace transform of e to the 3t cos, let's say 4t. And this is what we have. So the first thing you will want to do is to find the Laplace transform of cos 4t. And remember what this would be. So this would be s divided by s squared minus 4 squared. This is what this is going to become. So this is s divided by s squared minus 16. So this is what we have. This is the Laplace transform of cos 4t. Remember, check the previous videos. All of this, it's a build-up process. So you need those ones to understand this very well. So this is what we have. Now, e to the 3t means to get the Laplace transform of e to the 3t cos 4t. What I'm going to do is, anywhere I see s, I'm going to be replacing it with s minus 3. Remember I said, if this part is positive, that means you're going to be replacing with s minus that very number. So here we have 3. So we're going to be replacing s with s minus that 3. So this is s. We're going to say s minus 3 divided by s minus 3 squared, then minus 16. Now we can simplify this to become s minus 3 divided by, we're going to be squaring this. And this will become s squared minus 6s plus 9. Yep, I opened this a little bit fast. Let me just work it here. S minus 3 squared is s minus 3 into s minus 3. Now s times s is s squared. S times minus 3 is minus 3s. Minus 3 times s again, minus 3x. And minus 3 times minus 3 is plus 9. So this will be s squared minus 6s plus 9. So that's why we have this. And then I'm going to put the minus 16 here. Now this will become s minus 3 divided by s squared minus 6s. This is plus 9 minus 16, which can be written as minus 7. So this is what we have. So this will be the simplification of that very problem. And let's take a look at another one. So that is number 2. Number 3, Laplace transform of e to negative t. Let's say we have sine this time around. Sine 7t. All right, let's say we have sine 7t. Now in this case, first thing we want to find is the Laplace transform of sine 7t. So first of all, the Laplace transform of this will give us 7 divided by s squared plus 7 squared. Remember, watch the previous videos because I've done all this in the previous video. So this will become 7 over s squared plus 49. So this is the Laplace transform of sine 7t. Now the Laplace transform of e to negative t sine 7t, anywhere I see s, I'm going to be replacing it with plus 1. Plus 1. So this will be 7 divided by s plus 1 squared plus 49. So this will become 7 over s plus 1 squared will give us s squared plus 2s plus 1. And then plus 49. So this will become 7 over s squared plus 2s plus 50. So that's what we have. So this will be the answer for that very portion. Remember, this s plus 1 squared, you can expand it like this and you get the same thing. Another example, that will be the last for this section. The Laplace transform of 2, then we have e to negative, let's say 4t, then which of them should I give now? Okay, let me still use t. T to the power of 2. Okay, I think that's better. Okay, so we're going to be doing this. So first things first, I need you to remember that you can rewrite this as the 2 coming to the front because the 2 is a constant multiple. So this will be 2 Laplace transform of e to the negative 4t t squared. So now let's find the Laplace transform of t to the power of 2. So the Laplace transform of t to the power of 2, this will become 2 factorial divided by s to the power of 2 plus 1. So 2 factorial is just 2 divided by s cubed. Now, to get this very answer, this will become, we have 2 Laplace transform of e to negative 4t t to the power of 2. Now, this will become, I'm going to write my 2 first, times, now, t to the power of 2 gave us 2 over s cubed. Now, anywhere I see s, I'm going to be replacing it with s plus 4. Because if this is minus, that will be plus. So this will be 2 divided by s plus 4 to the power of 3. Now, this will give us 4 divided by s plus 4 to the power of what? 3. So this is how we use the first shift theorem. Mathematically, that's all you have to do. So find the Laplace transform of the function, and then you replace s. Anywhere you see s, replace s with s plus a or s minus a, depending on what your the exponential is raised to. And with this, I'm going to call it the end of this very video. I'm going to see you in the next one. Bye.